The National Electrical Code, specifically Section 501.15 EON, addresses the sealing requirements for cables in Class 1 Division 2 locations. A key distinction must be made between tray cables and multiconductor tray cables. Multiconductor tray cables, as defined in Article 392 of the National Electrical Code, are recognized as having a gas or vapor-tight continuous sheath that can transmit gases or vapors through the cable core. Because of this characteristic, the National Electrical Code imposes specific sealing requirements. The third sentence of National Electrical Code Section 501.15 EON is applicable to terminations in non-explosion-proof enclosures. It states that multiconductor cables with a gas or vapor-tight continuous sheath capable of transmitting gases or vapors through the cable core must be sealed in a listed fitting in the Division 2 location. This requirement exists to prevent the migration of flammable gases or vapors through the cable and into other areas. Explosion-proof enclosures do not require listed fittings for cable seals. The requirement for a listed fitting indicates the intention to address non-explosion-proof enclosures. Considering the provided information, if the multiconductor tray cable being used possesses a gas or vapor-tight continuous sheath capable of transmitting gases or vapors through the cable core, a cable seal is required at the junction box inside the Class 1 Division 2 area. This requirement is based on National Electrical Code Section 501.15 EON. To summarize, firstly, understand the distinction between tray cables and multiconductor tray cables. Multiconductor tray cables are specifically defined as capable of transmitting gases or vapors through the cable core. Secondly, recognize that National Electrical Code Section 501.15 EON applies to non-explosion-proof enclosures when it references listed fittings for cable seals in Division 2 locations. Thirdly, if the multiconductor tray cable has a gas or vapor-tight continuous sheath, a cable seal is required at the termination point within the Class 1 Division 2 area, specifically in the non-explosion-proof junction box. The National Electrical Code 2005 Handbook Commentary Table 5.3 reinforces this understanding, indicating that cable seals in Class 1 Division 2 areas are required for multiconductor cables with a continuous sheath capable of transmitting through the cable core, but not necessarily for cables with a continuous sheath that are not multiconductor. When installing electrical equipment in hazardous locations, it is crucial to carefully review the National Electrical Code requirements and manufacturer's instructions to ensure compliance and maintain safety. Section 501.15 covers sealing and drainage requirements for Class 1 location. Within that section, subsection E specifically addresses cables. National Electrical Code 501.15 EON deals with cables entering enclosures that are required to be explosion-proof. This section details the requirements for sealing these cables to prevent the propagation of explosions from within the enclosure to the surrounding hazardous atmosphere. The section also addresses multiconductor cables with a gas or vapor-tight continuous sheath. For these cables, a listed fitting is required in the Division 2 location to prevent the transmission of gases or vapors through the cable core. National Electrical Code 501.15 E3 provides exceptions to the sealing requirements for certain cables. However, these exceptions do not apply if the cable is required to be sealed under National Electrical Code 501.15 EON. Article 392 of the National Electrical Code provides requirements for cable trays. Cable trays are support systems for cables and raceways. Multiconductor tray cables are often used in cable tray systems. The National Electrical Code definition of multiconductor tray cable emphasizes its ability to transmit gases or vapors through the cable core. This characteristic is a key factor in determining the sealing requirements in hazardous locations. The intention behind the National Electrical Code requirements for sealing cables is to prevent explosions and fires. By sealing cables, the migration of flammable gases and vapors is restricted, thus reducing the risk of ignition. The National Electrical Code Handbook provides interpretations and explanations of the National Electrical Code requirement. The handbook can be a valuable resource for understanding the intent behind the code and how to apply it correctly. When working in Class 1 Division 2 locations, it is essential to consult the National Electrical Code and any applicable local codes or regulations. These codes provide the minimum requirements for electrical safety. It is also important to follow the manufacturer's instructions for all electrical equipment and materials. Proper installation and maintenance are crucial for ensuring the safety of electrical systems in hazardous locations. In addition to sealing requirements, other factors must be considered when installing electrical equipment in Class 1 Division 2 locations. These factors include the temperature rating of the equipment, the type of enclosure, and the wiring methods used. All electrical equipment must be suitable for the specific hazardous environment in which it is installed. Regular inspections and maintenance are essential for identifying and correcting any potential hazards. Electrical systems in hazardous locations should be inspected by qualified personnel on a regular basis. Any deficiencies should be corrected promptly to prevent accidents and ensure the safety of personnel and property. Continuous training and education are vital for electrical workers who work in hazardous locations. These workers must be knowledgeable about the National Electrical Code requirements, safe work practices, and the potential hazards associated with electrical work in these environments. By following the National Electrical Code and implementing safe work practices, the risks associated with electrical work in Class 1 Division 2 locations can be minimized. A thorough understanding of the code requirements and the characteristics of the hazardous environment is essential for ensuring electrical safety. Let's consider an example scenario. Suppose a manufacturing plant has a Class 1 Division 2 area where flammable solvents are used. A multiconductor tray cable is installed to provide power and control signals to equipment in this area. The cable has a gas or vapor-tight continuous sheath capable of transmitting gases or vapors through the cable core. The cable terminates in a non-explosion-proof junction box inside the Class 1 Division 2 area. According to National Electrical Code Section 501.15 EON, this cable must be sealed at the junction box. A listed fitting must be used to prevent the migration of flammable solvents through the cable and into other areas. The selection of the appropriate cable seal is critical. The seal must be compatible with the cable type and the hazardous environment. The seal must also be installed correctly to ensure a proper seal. The installation of the cable seal should be performed by qualified personnel who are familiar with the National Electrical Code requirements and the manufacturer's instructions. After the cable seal is installed, it should be inspected to verify that it is properly sealed and that there are no gaps or leaks. Regular inspections of the cable seal should be performed to ensure that it remains in good condition. If any damage or deterioration is detected, the seal should be replaced promptly. In addition to the cable seal, other safety measures should be implemented to minimize the risk of explosions and fires in the Class 1 Division 2 area. These measures may include ventilation, grounding, bonding, and the use of intrinsically safe equipment. A comprehensive safety program should be developed and implemented to address all potential hazards. A safety program should include regular training, inspections, and audits. All personnel who work in the Class 1 Division 2 area should be familiar with the safety program and their responsibilities. By implementing a comprehensive safety program and following the National Electrical Code requirements, the risks associated with electrical work in Class 1 Division 2 locations can be effectively managed. The distinction between tray cables and multiconductor tray cables is crucial in determining the appropriate sealing requirements. Tray cables are general-purpose cables that are typically used in cable tray systems. Multiconductor tray cables, on the other hand, are specifically designed for use in hazardous locations and are constructed with a gas or vapor-tight continuous sheath. The presence of the sheath necessitates the use of cable seals to prevent the migration of flammable gases and vapors. The interpretation of National Electrical Code Section 501.15 EON is essential for understanding the sealing requirements for cables in Class 1 Division 2 locations. The third sentence of this section clearly states that multiconductor cables with a gas or vapor-tight continuous sheath must be sealed in a listed fitting in the Division 2 location. This requirement applies regardless of whether the enclosure is explosion-proof or non-explosion-proof. The use of a listed fitting is a key indicator that the requirement applies to non-explosion-proof enclosures. Explosion-proof enclosures are designed to contain explosions, so they do not require listed fittings for cable seals. The requirement for cable seals is based on the need to prevent the migration of flammable gases and vapors through the cable core. This migration can create a hazardous condition in other areas of the facility. By sealing the cable, the risk of explosion and fire is significantly reduced. In conclusion, the National Electrical Code requires cable seals for multiconductor tray cables with a gas or vapor-type continuous sheath that terminate in non-explosion-proof junction boxes inside Class 1 Division 2 areas. This requirement is intended to prevent the migration of flammable gases and vapors and to ensure the safety of personnel and property. It is important to consult the National Electrical Code and any applicable local codes or regulations to ensure compliance with all applicable requirements.